let me go ahead and jump right in because of the time that we are constrained to. Um, so this first piece is just kind of covering uh, the cycle and the lifespan of what we're going to be doing and kind of bringing everything together. So you're going to be introduced during the kickoff to the mentors, and the mentors have like a 1 minute pitch of the idea that they are bringing, and the idea is that some of you will be attracted to different projects that you'll be wanting to be interested in working on. Amy, do you have admit rights?
Yes, I do. I just handled it.
Okay, perfect. That way I don't keep trying to click on it.
Yeah, I
Um,
got it.
so, really quickly, this slide deck is just an example of a project that we did at supercomputing, and I wanted to kind of just talk through these things fairly quickly. I'm sure that Dr. Hayden has uh, kind of briefed a lot of you on the kind of event, what it is, and why it would be interesting to be a part of it. But really quickly, just going to go through these different phases. So the first thing is kind of coming up with what it is you're going to try to do, and the challenge that I run into myself is that I often look at really big projects. I've worked on really big projects, and I like to think big, but you have to be realistic about what it is you're going to try to solve. Maybe your idea is really great, and you still want to move forward with it, and it just requires that maybe you pare it down in terms of scale or scope so that you can still be successful in delivering something, but maybe not as ambitiously as you might have first thought. So this is a project that won in Supercomputing 2019, and the team was called SMS to CCQ. So as most of you probably know, SMS is simple messaging service, aka text messaging, and 2 is just the word TO, and then CCQ, which is a part of Cloudy Cluster, which we will be uh, actually diving more deeply into today in terms of looking at it. And the goal was to take a third-party tool like Twilio and build a chatbot that would talk to CCQ, get the status of jobs that have been submitted to the cloud, and then be able to check status of jobs that you'd submitted to see where they were. So that required Cloudy Cluster, which hopefully everyone's projects will be inclusive of Cloudy Cluster, Twilio, and then some Python scripting that actually had to be created from scratch to make this work with their APIs and our APIs and everything coming together. This is an actual screenshot uh, of the project, and it was a successful project. And so I want to use this as an example as we go through this. So, I forgot to edit out Atlanta. So last year there was a theme because the conference was based in Atlanta that there was a focus. So don't worry about that. But um, the one thing you're going to want to do is get input from everybody on your team, and then think about what you're trying to do and who the audience is. And I don't think it matters necessarily who the audience is as long as you can articulate that and identify who the audience is. And then is it something that you're interested in? And not everybody has to be 100% interested, but if everybody just kind of says, well, then maybe you need to find something that you're going to be more excited about doing. And then,
Excuse
like
me,
I said,
Rich.
yes.
Sorry to bug you. I think Marcus actually has a question for you.
Oh, I'm sorry. I hid the toolbar.
Oh no, I just had my hand raised up for first timers. I just didn't take it down. I'm sorry.
Oh, not a problem. Okay, just making sure. Sorry about that, Rich.
No, no problem. So as I mentioned earlier, just you want to keep your expectations in check, and that's part of what the mentor is for. And so as you start brainstorming on your ideas, and it will probably morph into something different, just make sure that you're looking at the scale, the scope, and then in terms of scale, one of the other things that can really win bonus points is if this could be used in other areas or in other ways with larger populations or groups. The judges will look at that as a very smart project that is something that can grow outside of the hackathon and be even bigger. All right. Oop. Okay, so the 5 stages of team development, and this kind of goes to organizational management and organizational behavior that some of you may have heard of before, but these are actual researched topics that kind of come together, and it's forming. So that sort of first night you're going to be forming a team. Storming is where it's kind of chaotic and you're kind of learning people's names and figuring out who can do what and whose personalities you get along with better or whatever the case is. And then norming is where you're kind of really actually coming together as a team, and performing is just about where you get to by the very end of the hackathon. And then adjourning is when the team dissolves or people start to leave and move on. And this is something that you'll face throughout your life. In companies, in universities, it's just part of teamwork. And so unless you somehow manage to work 100% solo for your entire life, you'll probably deal with these kinds of dynamics. So the other thing that we will want to take a look at, not only as mentors but also as organizers, if we end up with a team of 5 people who are all graphic designers, then we might need to switch things up. If we have a team that's 100% Python developers, then we might want to break that up and spread that talent pool into other teams. So again, just be flexible, be willing to adapt to the changes, because part of the forming is going to be guided by the organizers to make sure that the teams are well suited to be successful. So then there comes the how of what tools are you going to use. So one of the underlying or 2 of the underlying technologies that are being provided because of sponsorship for the hackathon, Cloudy Cluster is where I'm coming from, and Amy and Boyd, and we are giving you the software that can run high performance computing, high throughput computing, kind of like building a supercomputer in the cloud. And we're going to actually look at that in just a few minutes. But then also we have other sponsors like Google who are providing credits so that everybody can use the cloud. And then we will of course be using Google Cloud as the cloud for the projects. So this is where your skills, your experience, your curiosity, and what's available all comes together to then figure out how you solve the problem. What mix of these different things are you going to use? And then managing time. So we've had people who've literally worked for like 72 hours straight and didn't sleep, and we don't necessarily recommend that. We want to encourage you to have some balance, and then we also want you to share the workload, because in those cases it's usually one person who's charging ahead and not the entire team is equally being supportive. And then you're going to experience disruptions. Some of those are by design. Jamie will pop up and say, he'll send out a message through Slack that we're all going to have a pop-up task or challenge, and there's prizes involved and different incentives to be a part of all of those things. And and some of it is done purposely so that you can see where you are with where you should be in terms of progression. But again, flexible, adaptive, and also having somebody on the team who might be kind of acting as a project manager, who could also be kind of watching the clock to make sure that expectations are lining up with time and milestones and different things. Again, this is very time bound, but it is very doable as well. So just like building a building, you need foundations, and so one of the things you want to work towards is kind of your minimum viable project, or your MVP product, minimum viable product. So, you know, find out what you need, learn about the different data sets or the data sources, get to that sort of hello world that you've probably all experienced, and then start to put that together into what would be called a proof of concept, or like an MVP. Then start to bolt on and add the complexities up to the point where you can't do anymore because of time, and build it in a way that will be presentable. And because what you don't want is to necessarily just show a block of code. You're going to want to create some kind of user interface, or in the case of the text messaging, we were able to watch them text to the cloud in real time and get status updates. And so obviously that's a really cool thing to see a live demo of things working and happening. So think through that as part of, you know, how you're going to, sorry, I'm going to get rid of the waiting room. There we go. Think through how you're going to do all that, and look at it in stages. And again, your mentor will be there to guide you in getting those kinds of visible checkpoints in place. And every time I click. All right, so just in conclusion, one of the big things is just communicate. We've had times where people just kind of turn off their camera and they disappear. They don't respond to verbal, they don't respond to written communications, the Slack communications. It's really important that you engage and be a part of the team effort. And one of the best ways to make sure that you're staying engaged is just turn on your camera. Even if you're head down working, have headphones on and you're working, at least we know that you're alive and that you're participating and that you're helping out. Keep your expectations real, and just be prepared for the daily check-ins. There's typically a morning check-in, or like a mid-morning check-in, and then the evening check-in before dinner time. And then just keep focusing on what you're going to deliver, and it can morph, it can evolve, and it will probably have to. And just, you know, the key thing here is to be as flexible and adaptable to the changing requirements or obstacles that you run into that might require you to change and pivot and go in a different direction. So I will go ahead and pause and kind of come out of full screen mode here and see if anybody has any questions before we jump into the other piece of today's training. And I'll take a water break. Hopefully I didn't put everybody to sleep.
Rich, if we have 5 minutes at the end, can we have the participants introduce themselves?
Oh, I'd love that.
Yeah, so we get an initial understanding of who they are.
Anybody? Well, I guess I did such a great job that I don't have to slow down.
Can I go?
Yes.
Hello, everybody. I'm Dr. Monene Kanampio. I'm at Winston-Salem State University. I was out of the office for a little while. Dr. Hayden was very kind. She's been informing me of what was going on. The problem out there is sometimes internet is an issue depending on where you are. So I'm so glad to be back. And thank you very much, Dr. Hayden. Hello, everybody again.
Thank you for being here.
Videos of past training events are available on the GitHub site if you want to get caught up.
Jean-Pierre, welcome. I love your name. You've got a French first name and an Italian last name. Jean-Pierre Bianchi. JP, okay. Or is it JP? Je parle français, donc je m'excuse. Ah, voilà.
Impressive.
All right, well, let's go ahead and kick off a look at Cloudy Cluster. So, I'll go ahead and share my screen again. Now, just to kind of set the stage, many of you may not even be familiar with high performance computing or have even worked on the computing environment that your campus may have available. That's okay. But what we want to do is just kind of introduce you to the interface so that you are familiar with what Cloudy Cluster is and what it will be able to do for you. And like JP just said, he has a kind of a focus in machine learning, and that's fantastic. Hang on one second. Oh, okay. Oh, sorry. Yep, it just popped up. Yep. Sorry, my co-host who's helping got disconnected. So, all right. So back to what we will here at OmniBond, the Cloudy Cluster team, we will set up projects, Google Cloud projects, which is kind of like your own workspace in the cloud that you will have access to for your team, and that will give you access to storage. It will give you access to different API engines, Cloudy Cluster, which will also have virtual machines inside of that Cloudy Cluster environment, as well as you could use Kubernetes containers, Docker containers. There's a variety of tools. This is the full cloud, but Google has kindly provided us with credits, and so it doesn't mean that we want everybody to spend millions of dollars on the cloud. We do want to be smart with our usage of the cloud. So again, the mentor will be able to help you with planning, and if you have any questions at all, use the Slack channel to ask if it's okay to use X number of computing instances or types, and we will help you balance between the budget that we've been given as well as the resources that you need to be successful. So when you log into Cloudy Cluster for the first time, this is the screen that you're presented with, and I'll just quickly go through these other 5 areas here. The dashboard gives you, and right now it's going to look flat because I'm not doing anything with it, but it'll show you how many environments you have and what's running in real time. And right now I'm not running anything at all. So it doesn't look very dynamic, but that's an area where you can go look at what's happening with your environment. Oh, I wanted to go back here. So access, this will give you access information if you want to log in directly to an interactive area. It'll give you SSH information, and each team will have its own setup for using Cloudy Cluster. Dr. K, okay. Yep, I am sharing. So let me just stop sharing real quick and I will reshare in case it didn't pick up for you. Hopefully that comes back for you. Within this area, probably the most likely tool that you'll use is the OpenOnDemand, and that will give you, we will take a look at that. This will give you an interactive method of using Cloudy Cluster and the cloud, and it has a great feature for leveraging Jupyter notebooks in the cloud, and you can also leverage that in a very collaborative way. So if you've ever used something like Google Colab, it'll be very similar to that, but instead of losing your work, you can keep your work from session to session. So it'll be a really good tool for testing any Python code that you might be wanting to leverage. Collaborations is where you can set up separate teams. I would say we will not be using that as part of the hackathon. Your team will have its own Cloudy Cluster environment, so you don't need to further separate those settings. Settings, again, not going to be worried about that. That's where you can manage passwords and things like that. And you're going to want to, all share the same password so that it's being, it's not getting cut off and losing track of. So then administration is where we would manage other security elements. And again, don't worry about that area. When you connect, when you see the landing page here, you'll go straight to the overview page. And what you're seeing right now is the environment that I set up. And we've got all these little squares in these separate, swim lanes. And what each of these represents is a different virtual machine or server in the cloud. So I have a login node, a scheduler node. I've got actually two schedulers here for demonstration purposes. I've got one that's running a version called Slurm and another called Torque. And then this, you can see this one is still green. This one is my Google Cloud Storage bucket. And every one of your Cloudy Cluster environments comes with its own bucket connected to it, and it stays live even if your environment is paused like this is right now. And that way you can upload and manage data without having the cluster running. Again, because if you're not using Cloudy Cluster, it's smart to just go ahead and hit the stop button to stop all these pieces from running and using up the budget. Here I've got 4 nodes that represent my file system, and I've got my storage that you will be able to use, and it's spread across whatever number of nodes are configured. Yours will probably have 2, but you can have 4, you can have 8. The difference is just in how big you need the storage. And if for some reason your storage is insufficiently configured from the beginning because of a data size that you need to use for your jobs, talk to your mentor or reach out to the support channel in Slack, and we can help you with that. And then down here is your networking, and this is all of these pieces are built automatically when you launch Cloudy Cluster. You tell it certain configurations, like which scheduler, how much storage to use, and then it spins up and is ready to go. I'll go ahead and hit the play button so that you can see from a paused state how long it takes to be ready to use the cloud. And so I'm just going to wait for just a minute, and if you have any questions, go ahead and just unmute yourself and let me know if you have any questions. I've got to take care of a couple of people here. Okay. All right. So just like that, you can see that everything is now fully green in the borders. And we're going to just wait for a minute because you can see that login is provisioning and scheduler is staging. So we want to see a green halo around each of the squares as well as the outer lanes. Andy, we started about 30 minutes ago, but we are recording. I'm going to pop over to the access area and grab this link because this will be a part of the demo. How many of you are familiar with high performance computing or high throughput computing? Go ahead and just type in the chat like yes or no. Parker's yes. Looks like we're a little 50-50 so far. This is great. So I'm just going to touch on it really quickly, and I'm going to actually click on this link here and come back to the overview. And let's just take a look at the status. I think we're good to go because this, yep. So now you can see that there's a green halo around all of the squares within each of these swim lanes, and that means that all of them are now running. And I'm actually going to pop over to the console really quick and give you a visual representation of what that looks like in Google Cloud itself. So and I'm going to have to switch Google accounts. Too many Google accounts. There we go. This is an area that you will have access to. And again, the hackathon is this much competition and this much about learning and getting experience and having some fun and being able to put this on a resume and kind of gain something. Great. Thanks all for telling me where you're at with high performance computing. It is a very small niche of the world of computing, but it's incredibly powerful and important. There are currently 100 projects that are working specifically in one group on finding a cure for COVID, and it's all being done with high performance computing, crunching the numbers, crunching the chemical compounds, and simulating what they will do in an effort to find a cure. So I came over here just to quickly show you that when we spun up the paused instance, Cloudy Cluster came into Google Cloud and said, hey, we need these resources to be live. And then the console said, you got it. I will make those resources available to you. And if you scroll down to the next page, you can see we've got a lot of projects here internally that we work on. So here you go. Rich demo is where we started, and when I told it to go back to a live running state, it reactivated all of these. There's our 4 file storage, there's our login, there's our 2 schedulers, and then this is the control node. So this is what's all running, and this all actually costs money. And so, like I said, if you aren't using it and you're just doing pure development, then you can pause it, and it only takes a couple of minutes to bring it back to life. So just something to keep in mind. Now, that link that I showed you on the access page with this interesting port number at the end of it, what you get from this is to an area where we have collaborated with a group or a platform called OpenOnDemand that was developed at the Ohio Supercomputing Center, which was a multi-university collaboration. And this gives you kind of a more graphical interface to use Cloudy Cluster and use high performance computing opportunities. So one of the things you can do is you can say, I want to run a Jupyter server, and then the interface asks you how long you want to run it and what kind of machine, and it defaults to an N1 standard. And if you do need a GPU, you can select it. And I would just say, before you do that, check with your mentor to make sure that you really need a GPU, and then before you kick it off. They are kind of the more expensive type of processing units that are available in the cloud. So if you choose none, then none will occur, even though there's a number 1 here. And I'm just going to go ahead and submit that request and get that started. And you'll see a message saying that the session was successfully created. And what's happening now over in the Google Cloud Console is another resource is spinning open for you to have access to. So if you log in and you see that someone has a Jupyter session that's already running, then you can ping your team and say, hey, who's got the Jupyter server running, and just communicate, because there's no need for everyone to spin up their own. These are powerful systems that you will be able to share and have access to. So that'll take a couple of minutes to do that. The other thing that you can do is run a Linux desktop, virtual desktop, on a server. So if you are more familiar with running Ubuntu or Red Hat or SUSE or one of the other Linux builds, you might be more comfortable with a drag and drop environment interface like the Cloudy Desktop will build for you. Another piece of the this will take you to a command prompt in the cloud on your server. So just say yes, and then it'll ask you for the password that you've been provided for your team's access, and then hopefully it'll let you in. Okay. I'm not going to lock myself out, so I'm going to leave that alone for a second. I think I might have typed it with caps lock. And let's see what's happening here. Almost ready. Any questions about what you're seeing so far? You're probably thinking, okay, well, so what? Why is Rich showing us Cloudy Cluster? And if you do have any questions, either go ahead and interrupt me with your voice, or type something into the chat. But what I want to kind of explain is that, let's say that you want to review the number of cells in a picture from a microscope. And using machine learning, you've trained the software to recognize what it is you're looking for. So you've given it pictures of bricks, pictures of bushes, pictures of cells, and maybe pictures of a different type of cell or amoebas or something. And you've gone through repetitively, and it has learned how to recognize what it is you're looking for. And then once you've achieved that learned state, you could ask your program to use Cloudy Cluster to then scan 100,000 images and count the number of cells in each one of those images, and then give you back an answer. Now, if you did that on your MacBook Air, it might take a year for it to finish, and you would not be able to use your computer that entire time. If you use Cloudy Cluster, it might finish in an hour, and you would have your results, and you would be able to then write about your results much faster than if you tried to do it with your own machine that you then couldn't even use because it's being used to its fullest capacity. So what we did here at OmniBond is to create an environment that will spin open these resources, do the computing, and then it will tear down the resources that are no longer needed after the job is done. And then you can also stop the environment to stop any billing. And Jamie, who is unable to be with us for this meeting, he works at TAC, Texas Advanced Computing Center, which is kind of a part of University of Texas at Austin. And I know some of you here are from the school. They have a supercomputer there that I believe was approximately $400 million to buy and implement, and then they maintain it and cool it and power it. And we are not trying to replace that, because it's, you know, those type of supercomputers are just amazing. But not everybody has access to one of those. And what Cloudy Cluster has done is kind of created an opportunity for researchers or research students, grad students, undergraduate, to use a similar type of configuration without needing to spend lots and lots of money. And so we are kind of like an extension of those types of environments, because you know, you might have an older computer on your campus, that doesn't even have GPUs. So if you need GPUs, you could run your job in Cloudy Cluster and have it tear down and not have to spend the money or capital to obtain those resources for your lab or for your school. And we've tried to make it very similar to the workflow that you would experience if you were to go to your computing department and say, hey, I have a job that I would like to run. We've made it as close to that as we could, but there are differences because of the cloud. And I just want to look at the chat. I believe, okay, yeah. So JP is a machine learning specialist. If your mic is still not working, feel free to just type in something that I may have missed in describing that machine learning, actual learning process for everybody to kind of catch up on. I'm going to pop over here and check, and so I think that my password has been changed, so I have to get that sorted out. But this will be green and ready for you to be able to launch into a Jupyter notebook and test your code. And like I said, others can log into the same notebook and work on different cells, and then all you have to do is save your work so that it isn't overwritten or lost. So built into Cloudy Cluster, if you go to the login node, you'll see a link for a terminal, and that's what I just launched. And so what this has done is has remotely connected into my login node. And so I'm just going to show you that I've got stuff that I've been installing here. If you see here, I've got WRF, which is weather research forecasting software. We've got R Studio for anybody who has endured statistics. You've probably run across R. And then there's another component of it called Futures. But one of the great things about Cloudy Cluster as well, and I'm not trying to boast on it, I'm just saying that we've put some pieces together here to make it easier and faster for you all to get ready to go. If I change directories and I go to the software directory, you can see that we have built in a number of software tools and libraries, and I won't go through all of these, but included in here is molecular dynamics, computational fluid dynamics, molecular research with PyMol, Relion is actually cryo-EM research software. And then of course we've got the CUDA toolkit for anybody who wants to write something using the NVIDIA CUDA toolkit for GPU. The project that I'm going to be proposing uses Blender, or will use Blender if it's used. And Amber Tools is also another molecular modeling software. So we've got a lot of software and a lot more than this. There's about 300 different pieces of software that are installed. So we've tried to make it very quick for you to develop the code that would be able to run very quickly using this. And if you needed additional software that isn't installed, then you can simply go to that web page, find out what the installation process is, and install it onto your cluster, and then test your code and go for it. So again, what this interface is giving you access to is all of those virtual machines that are sitting ready for you to do something in the cloud right now. And so we will talk more about that, but you get kind of higher marks on your judging if you can come up with a project that will use Cloudy Cluster as part of the workflow. You have the Google Cloud resources available to you, but if you can figure out a way to define a project that requires a research computing component, it will be more advantageous for you in the scoring components. So again, I'm not dictating anything. You guys need to work on your own project ideas and evolution, but this is a really good way for you to learn about high performance computing and to compete well in the competition portion of the hackathon. And so with that, I mean, I could go on for hours because there's so much, I mean, probably more like days, because there's so much power in cloud computing, in high performance computing, and at this point, without having any project focus ideas, it doesn't make a lot of sense to go any deeper into what we're using here. But the key is we want you to get familiar with what it looks like to be connected to Cloudy Cluster, and what the interface looks like, and how quickly you can just jump right into the server and start doing things. And then I think one of the things, if it's not up, I will ask that we get it on to the website for some Linux commands. So any of you who are not really familiar with using this kind of interface, the command prompt or the command line, then you would benefit from just kind of having a cheat sheet of how to move around, how to make directories, how to rename things, and how to see what's in the directories. So kind of like a top 10 Linux commands that you may not be familiar with at this point in time. So I'll make sure that we have something like that available to aid in navigating the back end of this. So with that, I think we have just about 10 minutes left, and Andy, yes, we'll get the recording published and the link out as soon as Jamie lands back in cell phone range. So as per Dr. Hayden's request, I don't have any particular order. Dr. Hayden, do you want to kind of call out names, or should we just?
Sure, I can handle that.
Okay.
So welcome to our second hackathon training. Thanks. Good job, Rich. Appreciate your introduction to the use of these Cloud Cluster resources. This tape will be available at on our GitHub site that you can reach by going to hackhpc.org. hackhpc.org. In the upper right-hand corner, there'll be a link to the GitHub repository. And as soon as we possibly can, we'll get this recording up and available. If you missed the past training, then it's already up and you can view it. Each session is about 60 minutes long, and it's available at the same repository. Also available there is a schedule as we look forward to our future training and our actual hackathon event. And you can make note of the check-in times and the other points there of that you need to know about how to participate, how to connect, and the resources that have been made available. So I encourage you to explore that GitHub site for our hackathon. So we wanted to take a minute just to have you introduce yourselves. When you introduce yourself, we want to tell who you are, what institutions you are, where you're going to school, what your major is, maybe something about you, like why you're interested in this hackathon. But we want to limit it to most 2 minutes. Try to keep it to 1, but at most 2 minutes. And we'll get started with Andrea, then AO, and Sharif and Shinadu. So unmute yourself and turn your video on so we can see you. That was Andrea, AO, Sharif, and Shinadu.
Hi, my name's Andrea. I am a rising sophomore at the University of Illinois, Urbana-Champaign. I'm studying industrial engineering, and I'm doing the SGCI Coding Institute. The reason I did the Coding Institute is to improve my coding and professional skills. And I'm doing this hackathon to put those skills that I learned in the workshop to use and to continue to learn more coding.
Great. Good job, Andrea. Ayo.
Good morning, everyone. My name is Ayomide Olatunde. I'm a Nigerian. At I'm an undergraduate student at Mississippi Valley State University. Currently the lead for Google Student Developers Club at my university. Um, I'm very glad that I joined SGCI because I discovered that there's a lot of backend that are being taught in SGCI, and that's something I'm quite excited about. I actually started learning how to use Unix here for the first time, and I'm very grateful for that. I'm looking into just software development or cybersecurity, and I hope that the knowledge and skills that I acquire from this coding institute will help me to move further into that. And I'm also looking forward to connecting to more people. Thank you.
Good. Thank you, Ayo. Sharif Shinadu.
Okay, hello, my name is Cherith Kay. I'm currently a rising junior at Winston-Salem State University, and I major in information technology. After I graduate with my master's, I plan on going to a career field of cybersecurity. And that's why I joined this program, because I feel like it will give me the skills I need to be successful in my career. And I feel like the hackathon will also be a great opportunity and a good experience to just learn. So my mission is to help improve and protect technology over time as it evolves.
Thank you.
Thank you. Yes.
Okay, Shinadu.
Good morning. My name is Chidma Chinedu. I'm a rising sophomore in Mississippi Valley State University. My major is computer science. And when I graduate, I hope to work in aviation and cybersecurity. I joined this HGCI program to help me improve my skills. And this program has actually open my eyes that I actually have a lot to learn. There is a lot of stuff that I do not know. So now I'm like more hungry to learn stuff because sometimes I get lost. I'm like, I have to go and learn stuff outside. So that's one of the stuff that I know I learned from this HGCI. And I want to participate in this hackathon also to put the skills that I've learned into hands-on practice, and also to meet mentors that will give me the knowledge that I require.
Thank you. All right, Andy, and then Akulea from Spelman. Okay, we'll follow.
Hello, everyone.
Hi.
My name's Andy, and I'm an incoming graduate student at San Jose State University. And I'm very fortunate to find out this opportunity, this hackathon, because I thought that this is going to be a great opportunity to learn about high performance computing and the tools that I would need to be to use in my work to be successful in the future.
Good. Thank you, Andy. Welcome. Okay. I, Spellman. Oh,
hey,
doesn't work. Okay.
Yeah, my phone's messed up and my laptop mic doesn't work, so we're in between. But my name is Ayomide Akulea. I go to Spelman College. I'm a computer science major. I'm a senior. I learned through this program through my friend Parker. And I just was really interested when he told me about the hackathon. I think hackathons are fun. And I think it's a great time to meet other people who are also in my field and learn and, just code together type of thing.
Good. Welcome.
Thank you.
All right, Christopher, then Jasmine, and Jay-Woo.
All right, good morning, everybody. I'm sorry my camera doesn't seem to be working at the moment, but hello, my name is Christopher Metalis. I'm a rising senior majoring in mechanical engineering at the University of Illinois Urbana-Champaign. This past semester, I had the privilege of working alongside Professor Van der Zand on studying organic materials and how they respond to applied strains. Unfortunately, during this research experience, I realized I had a subpar knowledge of programming in general, and that's what motivated me to apply to this Science Gateway Community Institute. And through this institute, I have learned a lot about the basics of Python and how I can apply that to research I plan to do in the future. And considering that I also would like to pursue graduate school after I'm done obtaining my bachelor's degree, I find that computer science would be very useful to have as a tool to express my research and share it with others. So I believe that I would benefit very greatly from this program, and that's pretty much all about me.
Thank you. Good
That's
job.
great. And just so you know, for those of you who are not computer science specific, the one of the things that I do or try to do is learn as much as I can about different areas of science. And so in the past, I've done simulations using molecular dynamics software, where you can collide different atoms and molecules of different components like copper and aluminum together in a virtual box to see what that looks like after a certain amount of time and what kind of chemical structure you're left with. So if you're looking at material sciences, one of the things that you may have heard people joke about unobtainium. Well, there are new alloys being constantly developed for different things, and that's where that comes from, and that's a kind of purpose behind high performance computing, because well, first of all, you could do that physically. It wouldn't be easy, and it would take time and money that would be recuperated much faster if you did it virtually before you spent the time and money to use resources. So that's a great example.
Great.
Thank you, Christopher.
Good, Chris.
Sorry, Jasmine.
So we will go on with Jasmine, Jiwoo, Jocelyn, and Lena.
Okay, hi guys. My name is Jasmine. I'm a junior at Winston-Salem State University, majoring in computer science. I'm thinking about either going into just full stack development or artificial intelligence with a focus on data analytics for applications. I joined this program just to help me learn more and maybe help me figure out which area I want to go into. So yeah, thank you.
Yes, thank you, Jasmine.
Thank you.
Good morning. My name is Julie. I go to University of Illinois at Urbana-Champaign. I'm a rising sophomore there studying computer science, and I joined this program so that I could this would be my first hands-on experience, so outside of school activities. So that's the reason why I joined this program. Thank you.
Good. Glad to have you. That was Jiwoo. Go with Jocelyn, Lena. Jocelyn, then Lena.
Good morning, everyone. My name is Jasmine Salgado, and I'm currently one of the trainers for the 4-week boot camp that we have for SGCI. I'm currently a business marketing major, so this is actually completely different from my original field, which was environmental science. I've been with the program for about 2 years, and I'm extremely grateful to be here. And if there's any questions or comments, please let me know.
Thank you, Jocelyn. Lena? And Parker?
Oh, where is my video?
There you are.
Okay. I'm Alana Park, who recently finished my first year at the University of Illinois at Urbana-Champaign. And my major is computer science, and my interest is like backend coding and gaming fields and cybersecurity. And yeah, since high school, I have learned programming language called Java. And recently in college, I got to learn C++ and Python. But like, although I'm not yet expert in like all three languages, I hope to improve my coding skills throughout this coding institute. And I'm willing to use what I learned, like what I have learned through this coding institute, like to the hackathon. Yeah.
Good.
Thank you.
That's excellent.
Good job.
Did you see Jinwei on your list?
Jim Way is a faculty member.
Oh, okay.
Okay.
My next.
Parker, go ahead.
Hi. My name is Parker Broadnax. I'm a senior computer science major at Morehouse College. And I started this program to improve my coding skills. And eventually I want to go into AI and cybersecurity, but I need to brush up on Python and a lot of other computer science stuff. So I'm here having a great time.
Good. Great, Parker. I see Zaria and Trevion as students who have not introduced themselves. Zaria? Trevion?
Good morning, everyone. Hi, good morning, everyone. My name is Zaria Thompson. I am a computer science major at Winston-Salem State University, and I major in computer science. I joined this program to sharpen my coding skills and professional skills that I can apply in the classroom and in my career. My interests are cybersecurity, and yeah, I plan to pursue higher education in the future, and I just hope this program can help me prepare.
Good. Thank you, Zaria. And Trevion?
Can you hear me?
Yes.
My name is Trevion Lewis. I'm a sophomore at Mississippi Valley State University, majoring in computer science. I joined the program to learn some new things about coding and learn some new languages. And I hope once I graduate with my bachelor's, I hope to work in the cybersecurity field.
Good. All right. Did I miss? Did Nia speak? Did Nia speak? Nia Blake? Is Nia here?
I don't see Lee.
Okay, I don't see her in the list either. Did I miss any students?
We have Logan Durham.
Can you hear me?
Yes.
Yep. Okay, sorry. Yeah, I tried to turn my video on and it's going weird. But yeah, I'm a rising sophomore at Clemson University in the computer science department, and my major is just computer science, Bachelor of Science, and the first year we mainly did C and C++, and I figured it'd be more fun to go back to where in high school I took a Java class, so go back to working with Java and other languages other than based on C. And also it'd be interesting to just collaborate with people I haven't met before. And yeah.
Good. Welcome. Did we miss any other students? If so, just unmute. Good. Well, I have enjoyed hearing from each of you, and I look forward to spending more time virtually with you doing our hackathon. So I'll turn it back over to Rich now. We do need to close out. We got a hard stop coming.
Yep. Okay. Well, thanks everybody. That's great to have a little bit of background on you, and it sounds like we've got a really a strong population of programming backgrounds. So that'll be great because every team needs somebody who can actually write some code, and you're not limited if you decide that you've got someone who's really good at Java or JavaScript or Python. You can use your greatest strength and help others learn about those things and make successful outcomes using whatever tools you have available and what's going to work best. So excellent. And hopefully everybody's joined the Slack channel that was put out. If you have not, go ahead and either give a shout out or just raise your hand or something, and while we're doing that, I'll try and get you a link to join if you do not have it. And just something else to consider. I heard a lot of people talking about getting experience and wanting to meet new people and learn a little bit more. And all of those things are legitimately possible with this opportunity, this hackathon. And I would encourage you to actually do as many of these as you can throughout your college career, because I've met people who have computer science degrees who actually don't know how to write a program. When you work in isolated little tasks and modules and snippets for assignments, it doesn't necessarily teach you how to bring all those pieces together into something that's useful. So this is a great way to get that kind of practical hands-on experience. So I really commend you for being here, and stick to it. This is kind of a weird long short marathon where it's going to feel like you're going fast at times, and then there's others like, wow, is this ever going to end? And just stick with it and get the experience under your belt. And absolutely, you can put this on your resume, and we have a LinkedIn alumni group for hackathon participants and mentors, because I have people who've reached out to me and I've written recommendations for them because I legitimately worked with them, and I saw what kind of leadership skills they had. I saw how they did with teammates and what kind of skills they had.
Yeah.
And so we want to be able to support you and help you grow. And that's, I would say one of the core values of OmniBond with the Cloudy Cluster is that we want to support science and research. And maybe one of you will be the next Nobel Prize winner. And I say that half
That'd be
jokingly.
great.
But time to go.
That would be great. Yeah, it also teaches you how to work in a team.
Mm-hmm.
And that's all, the only way we accomplish things is to work together in teams, in most scientific groups. So I have to, we're gonna have to leave now. Go back immediately to our Zoom line that has the hackathon, not the hackathon, the Coding Institute instructors are waiting for you. Thank you very much. For those of you who are in the Coding Institute.
The Slack link is in the chat window if you need to click that to join.
All right. Great.
Thanks, everybody.
Thank you, Rich.
Thank you, everybody. Thank you so much, Rich.